the cloud.
Okay, welcome to the November 4th, 2025 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week I've been working on building some of my Whisper, or going through my Whisper Demon radios and trying to configure them in a way that makes it easier for me to manage them. And partway there, uh, also, I've been playing with some code that Michael wrote and got stuck. So uh, that's where I am with that. So that's about it for me. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. Things are going well here. Let's see. I'm very excited that we're going to have a research assistant starting next week on the Personal Space Weather Station and HamSCI projects. This is going to be a full-time person at the University of Scranton that I'm hoping will be able to help do things that include, really get the documentation together for uh, doing reproducible HamSCI personal space weather stations and be able to spend, more or less full time getting RX888s configured and a lot of other things. So I'm very excited about that happening. It, of course, won't solve all my problems overnight, but I think it is a path towards, getting to where we need to be. So I'm very excited about that. And I'm hoping that when she comes on, I'll be able to introduce her to you. And she probably won't be on this telecon very often. She'll probably be working more during the day. But I'm sure that she will be interacting with the different people on the call here. Let's see, I just reviewed another HamSCI newsletter that Ed Fcheck and Mary Lou West put together. So that's gone over to layout. So that's going along nicely. And my wife Rachel and Christine Zagziski and Majid have been making really good progress on their magnetometer setups set up at the university. So today they have Helmholtz coils put together, which I think we've shown you photos of before, but now we have it so they know how to drive the Helmholtz coils using an arbitrary function generator and can make the numbers change a little bit. And I have a student. I've got a new student who just emailed me today, who's a data science person, a computer science person. I'm thinking about possibly directing him to work on the magnetometer project if he ends up working with me, and maybe having him work on some real-time visualization software to help out with all of this. So I think that's good. One thing that was a little surprising, maybe I can show later in the session, is that I think Rachel mentioned to Dave Witten a few weeks ago that the magnetometer that we have in the lab would get into this state where it would be alternating in the X component between some very large value and some smaller value on 1 second cadences. And we saw that again today. And I actually Rachel took a video of it, which I can show. And sure enough, when she restarted the system, that problem went away. So we're not quite sure what caused it to get into this particular mode, whether it's just an oddity of this particular piece of hardware that we have, or if it's something representative of a bigger problem. But this is the first time we've seen it, but it does in fact seem to be real. So anyone who's interested, I could probably show a video of it later and we could talk about that. So that's kind of where I am. Back to net.
Okay. Next on the list, we have Clint, KA7 OEI. Sorry, Clint.
Hi, yeah, nothing too much exciting, although it's worth knowing that the Utah SDR, one of our B-links, has failed catastrophically. And it's our very newest computer on side. And now we're discovering how awkward it is to get any warranty repair on those B-links at all.
They
Uh,
have warranty repair.
Allegedly.
I thought you were the warranty repair, Clint.
No, I mean, no, there's I haven't seen it personally, but This is the B links, but
the B links. They're trying to get
B
I thought
links.
you meant the IEEE. So they're
Oh
trying to
no,
get
no,
warranty
no,
repair on
no.
the B links.
No, this is the B links.
Okay.
Yeah, there's some sort of goo that was left inside the computer when when the
Yeah.
covers were taken off, and we can't tell where they came from, except it doesn't work. But we
Okay.
were able to pull the hard drive out of it, and since it was virtualized, we're able to put it in another machine, but it's not as capable, so it
Right.
can't do what we wanted it to do. And what it was doing actually was running a VM running Windows for the CW skimmer. And so most of our skimmers are down. We had another machine. The CW skimmer software was written when 1.7 was the new thing. And there's something incredibly inefficient about the way it works. And you doesn't matter how powerful your machine is or how you virtualize it, you cannot a dual core machine or a 16 core machine will run about 8 skimmer instances. Period. That's all you can get out of it. So we have another machine running other instances on other bands, but not the main money bands like 80, 40, 30, 15, all those.
Mm.
So most of them are down. We're figuring out what to do exactly, but we'll worst case, we'll just get another B-Link or equivalent. And we'll see though, but considering how onerous it seems to be to get them B-Link itself to do any warranty work, we're not all that keen on replacing with another B-Link. Anyway, back to you, Dave.
Well, university surplus may be your friend.
Maybe.
Anyway, next on the list is David H. W6OQ. Go ahead, David.
Good evening, everyone. So this week, well, I participated in the call on the new whatever 888 that we're working on, and also dropped a comment today in the thread for that. Other than that, trying to decide how high the toilet should be in my bathroom. That's the highlight of my day. And also trying to tell an electrician that the aluminum wire he found, he could not just put the wire nuts back on it. Anyway, so not impressed with him. Okay,
No.
that's it.
Okay. Next on the list is Dave Julian, WB9YIG.
Good evening, folks. Yeah, not much going on here. I've been trying to resurrect a lightning strike Kenwood, and I'm about ready to fire it up. So we'll see if it produces more smoke. But other than that, that's it. Back to the net.
Okay. And next on the list is Dave Whitten, KD0EAG. Go ahead, Dave.
Going down the list of Daves here, you have to hit Dave McGaw next. Let's see. I did send off some more boards to be simple boards for the magnetometers to be manufactured. Got those out the door, and have been doing coding and such like, pretty much. Nothing of great excitement to most folks. That's it for me.
Okay. Next on the list is David McGaw, N1HAC. Go ahead, David.
Good evening. All I can say is Dave's not here, but
Sorry.
anyway, I've been working on our, receiving our CubeSat up in the air. If people aren't aware, it's called REAL and does appear on the satellite roster. But trying to pick up a beacon that we have on there with various antennas at this point, omnis rather than the big gain antenna that ultimately I'll be setting up. And I am being somewhat successful. So that's the excitement here, and seeing that we might be getting some snow over the next week. We have not gotten any snow, though. I saw flakes over the weekend, but nothing to accumulate. But the season keeps going and moving on, and I'm grateful that we're back to real time and not this artificial summertime. Back to net.
It's plus or minus an hour.
Yeah, well, it actually screws the system up.
Yes.
And the problem that I have is especially is it's not like jet lag, because when you're traveling, the sun changes.
Yes.
Nothing changed in reality, just the clocks. But
That's right.
we'll deal with it. Back
It's
to
even
net.
tougher when you have small children and you're trying
Oh,
to,
yeah.
Oh,
figure out their
yes.
bedtimes.
Well, I just saw someone refer to the fact that his cat clock doesn't change.
Yeah.
Tell me
Well,
about that. They got they I got rudely awakened this morning.
Uh,
yes. Okay. Well, let's go next on the list. We have a J. Jay Schwartz, WB8 SBI. Go ahead, Jay.
Good evening, everybody. It's been a few weeks here since I was able to check in. My big amateur radio thing was I attended the AMSAT annual meeting this year in Phoenix, Arizona. Had a good time there talking with everybody and getting caught up on what AMSAT is or isn't doing, and then doing general tourist things in Arizona. Uh, so Otherwise, just getting my travel schedule organized. Uh, Nathaniel, are you going to be going to the Radio Club of America annual meeting in Washington, D.C. this year?
I will be, and I'm giving a presentation too.
Oh, good. I'll see you there.
Wonderful. I'm
Great.
I'm taking my
So,
student Diego along with me.
Roger that. Yeah, so I'll see you there, and I'm getting my travel schedule organized uh, along those lines. Otherwise, just a lot of other personal stuff going on with sick relative and uh, other aches and pains that I have. Otherwise, nothing spectacular happening here, amateur radio wise, and so just reading the mail on everybody. 7-3 to all. Back to net.
Very good. Next on the list is John, W3 MHCZ. Go ahead.
Hi, let me try to pop in. It's John, Whiskey 3, Mike Hotel Zulu. Sorry, I'm here. I live in Center City, Philadelphia, so it gets a little bit noisy here, both via my windows and also on the radios. It's good to pop in. I've been following HamSCI for a while. I'm interested in very much in the meteor scatter activities you've been working on and the personal weather station. Love to have set one up in my house. Just haven't gotten around to it yet. I've also been working with the University of Pennsylvania Amateur Radio Club, and we've been working on setting up some antennas. We operated the other day on HF with some slopers out of our courtyard, and looking into HamSCI, the space-related activities are interesting to us because it's easier for us to deal with our antennas. So we hope to be able to tune in at least to some of the HamSCI activities. I know the Gemini meteor scatter is December 13, 14, 15, right around there, which is right in the middle of our final exams. But we would like to get a station set up that we can leave on permanently 24/7 up on campus to try to start ripping some signals and get intelligence
Whoop, he
to
froze.
undergrads who are interested in that. So we have a few undergrads that are interested in that, and we need to make some antennas for ourselves for our home stations, which will probably be 6-meter dipoles and 2-meter dipoles, simply just because we can. We have the wires and we can put them up in our spaces, and obviously making some Yagis for VHF, UHF might help us as well. But we're very much in the rebuilding stage and looking to piggyback and complement what everyone is doing up in HamSCI. Unfortunately, we didn't get to talk to W3USR on Jamboree on the Air during our luncheon. We ran into a DX competition in Germany, so our undergrads ended up working that. So we're just looking to stand by and learn. Thank you very much.
Very good. I bet.
And I just want to jump in and say, it's nice to see you on here, John. Thank you. I do
Just-
appreciate all of your emails. And I know you've been trying to get me involved in the Meshtastic and things like that. And I personally have just been totally time consumed with this, but we have a new professor here at the University of Scranton who's a computer engineering professor named Dr. Naveed Sharuzi, and he's interested in possibly participating in some of the mesh networking and stuff like that. And we started emailing today between him and Chris Casper and Peter Marchetto. So, and in case you're interested, Naveed is giving a IEEE seminar this Thursday at Scranton at noon. So if you wanted to come on up and meet him and chat with me a little bit, he's giving that talk, and there might be some time to talk a little bit.
Wonderful, wonderful. We have been looking at Meshtastic. For anyone not aware, it's a 913 megahertz off-grid communications. And also, Chris Casper is one of my buddies. Been talked to Chris quite a lot, and he was at our campus the other day. We are also looking for that on MCOMs, and I know Aries and Cliff have been looking at it. And right now, it's a little bit unreliable and sort of like the last mile, 2 mile level. So, but there is a way to accommodate it with antennas up high. It's just very sensitive to antenna height here in the city. So we are learning about that and testing it out. And we also are looking at ways to maybe do a crossover. We kind of want to set up a net on. We have 2 meter nets, maybe a 6 meter net, and there might be some ways to do crossover with Meshtastic. But it is interesting. And right now, for emergency comms, it's just not stable enough for us, which is a great opportunity for our students that maybe we can get some more stability there and use Meshtastic for our last mile versus a 2 meter or 440 rig or a 6 meter rig. So definitely something very interesting. And Chris has been a great help. So I will keep the IEEE thing in mind. Is there any chance there's a Zoom on that on Thursday? Because I'm not going to make it.
We don't have one planned at the moment, but there is a possibility. I'd have to talk with Naveed and make sure he was okay with it. And if he is okay with it, it's possible that we could open one up. I have a meeting owl, and that I could make that happen potentially.
Great. And we still have a CubeSat simulator we got from Villanova University, and we're hoping to get the students their resources on.
Yeah, we have one of those too from Alan Johnston. So
Right,
yeah,
we got ours from Alan as well. Alan sent us one as well. And really, what we would love to do, University of Pennsylvania has a high altitude balloon launch team.
okay,
For many years, and we'd love to put a CubeSat simulator in one of their high altitude balloons. It'd
yeah.
be good for our club to piggyback off the resources of their club, because our club is small now. We have probably 4 or 5 licensed amateurs, so that's one of the things. So many things going on, and the students always have various needs for their time, between exams and schools and interviewing. But we're looking to try to find low time commitment, fun activities for the students. So we'll be continuing to work with you.
That sounds wonderful. We'll get there. We'll get this collaboration going. It may take a little bit more time to get us all aligned, but we will get there.
Been doing it for years, man, and we'll continue to do it for more years.
Wonderful. Thank you for joining us tonight.
Okay. Next on the list is Jonathan, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. With the VLF project, what we're doing now is I'm going to continue with the design as planned. So I'm currently working on the VLF interface board, and I've made a decision on how I want to separate my separate the grounds from the loop side and the inside side. So they are going to be separated. So I'm working on the single channel version, and I also will be doing that for the 3-channel version, and that would be for an E-field and orthogonal loop antenna systems that I hope to eventually have. There was someone on the VLF group that built the 2-channel loop orthogonal system using Paul Nicholson's design, so that's kind of what I'm modeling everything after, everything that Paul did. So I'll be working on those, and that's going to complete the ensemble of boxes for the system, and then it's into the testing phase. So this Friday, I'm going to continue on building up some of the antennas, the E-field antennas, to get them to a point where I could pop in the preamps and test those out and see how well that they work. I took one of the pipes that I had, which I plan on using as a mast, to actually test one of these at home first, just to validate the preamp board design. So I'm pretty excited about that, and I'll hopefully talk more about VLF data products for the personal space weather station server, and talk with those pertinent parties on Friday. Also, just in case anyone is interested, the VLF group, there is some amateur activity, VLF amateur activity, which is always extremely interesting. 8.27 kilohertz and 5.17. A really nice activity from a ham in Germany. That's all I have. Back to the net.
Very good. And next on the list is Michael Howen, AC0G slash ND.
Slash ND and not a Dave, I'm afraid. Yeah, I'm up in North Dakota, my mom's house, and kind of on a walkabout. A little cold for camping, which I'm prepared to do, but hoping to get home probably within the next week or so. But I have been working on some stuff, and I'll be happy to share it with everybody a little bit later. I think the main thing is developed a Python library that exposes most of the stuff that Radio D will listen to, the commands it'll accept and so on. And so what that's enabled me to do is write a quick little app that will import the EIBI broadcast schedule that's put out twice a year of HF broadcast stations, and display it in a way where you can just click on any of the stations that happens to be on the air at the time that you're listening, and it'll display on it'll sound through your web browser, no matter where you are. And I'm still working on the signal recorder function for WWV, with the idea potentially of excising that from under the umbrella of Whisper Daemon, so Whisper Daemon doesn't have to worry about that, and it can record data independently. In particular, what I'm trying to do is store some of the metadata about the quality of the signal, so that not only is the data that we're currently capturing in Whisper Daemon there, but also variance from whatever the individual system time is, and RTP timestamps, and WWV per minute time signals. So just as an example, I wonder if I have it here. Maybe not. To share. Well, I'll share it later. Oh, there it is. It's quick. It's that this is an example of the per minute time tick. So this is 10 megahertz into Missouri. It starts a little bit after 200 milliseconds and extends 0.8 seconds. So I can use that front there as a time marker. And you can combine that with my longitude and latitude compared to WWV for rough time of flight at that frequency at that time, and compare it with RTP time and with system time. So hopefully that'll be an added level of metadata that'll make our collection of WWV data a little richer. That's it. Back to Nat.
Very good. And next on the list, we're going to go to Scott Newell in 5TNL. Go ahead.
Hey guys, just a reminder, the FMT is Thursday night, and this week I had a little bit of time to hack on some FX3 firmware. Tried to get the other LED to light up, but I guess the schematic online doesn't match my hardware, so I had no luck. And that's about it for me.
Okay. And then next on the list, we have Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave, everyone in the group. Let's see, I did the first design rule check on the quad receiver, and I think I must have set a record for a number of design rule violations. So there's going to be some work involved in tracking down, seeing which ones are don't cares and which ones are cares. This morning I got Open Web UI working. The intent is to try and load all the FX10 documentation into it, and then use AI to be able to ask questions to try and help me figure out how the FX10 should work. So interesting project perhaps. Anyway, back to the group.
Very good. And Tom, are you aware of the new hire that Nathaniel has and his expertise?
No, but that's interesting to note. Several folks have tried to get the state machine designer for the FX10, but Infineon's not apparently replied to folks. So maybe that's a possible ask there. That would be good news.
Yes. Did you get that, Nathaniel?
Yeah, so he is I got a little bit of it, but yes, I think it will be very interesting to see how Naveed might be able to connect us to what's going on at Infineon and give us some sort of better understanding of how these things are designed and how they work. I think he's very excited about how he might be able to work either with us or with some of these other projects. So I think he's going to be really, really good. From talking with him a bit, he said he was on the internal design team at Infineon. So he didn't work on the application side, but he said, now basically all he can work on are applications. So he's actually very interested in this other side of things. So I think he's going to be a good resource, and he is very excited to have people to work with and reasons to do what he's doing. So I think this is good.
Good.
Very good.
Yeah.
So next on the list is Rob Robinette. Go ahead, Rob.
Hi, I'm mostly working on the server, so it's not immediately relevant to any of you. I got a chat from Phil Karn. He's in Philadelphia, and so he can't join us tonight, but he's fine. He's just visiting his father. So, and I don't think I should inflict much else on you guys. Oh, K3LR. We've lost. There's it appears like the 888 has gone bad
Really?
there. Yeah. I don't know if you've been seeing George has been taking the lead.
Yes,
Really great.
I've been monitoring that, but I thought that he was able to get in and make progress.
He can get in and look at it. He has access to the computer,
Hmm.
but the 888 is disappeared from the B link. It just doesn't appear at all on the
And
USB.
and you had someone try and unplug it and replug it back
Yes,
in.
yes, yes. There's
You've done all of that.
yeah, we've
Well, I
done all
mean,
of that. We're
I
down to he's tried all the jacks. He's
yeah.
ordered a new USB cable, but I think somehow
I mean,
his
we can ship a new RX 888 out
I,
there.
I think that's what you're going to need to do tomorrow.
Okay. And
I'll send you an email.
our new research assistant is she she just graduated with her physics degree from Pittsburgh, so she's familiar with Western Pennsylvania. So maybe she's going to
Okay.
find herself on a road trip soon
She can,
back out to Western
yeah,
Pennsylvania.
yeah. For those of you who haven't been on this somewhat interminable email thread, the K3LR installation has a number of unique characteristics, but the one that's of greatest concern is that it has lots of RFI lines up above 10 megahertz. I mean, there are lots of switcher lines that appear. So George and has taken the lead in walking. Philip, I think, is the guy who's the Jessup or something who's there. Is George is guiding him through the diagnostic process of trying to eliminate these noise sources. And this process is not to try to suppress wall warts and so on, although that can be a component. But really, there's these unbalanced antennas. The DXE RSC antenna is an active probe with a ground rod. These these antenna designs are very susceptible to ground loop induced RFI, and the that's we don't know that that's the problem. I mean, it's possible that there's propagated RFI there, but I think that it's most likely that it's just that this antenna system needs careful monitoring and amelioration of these ground loops, RFI sources. Yeah, I think that we're going to see this at many sites. I think we saw it at your site, Nathaniel,
And probably still do.
and you still have it, And surprisingly, George did a lot of work and got rid of that on his RSC antenna at his home. So he's really the ideal person to be guiding these. But if we're going to do 20 installs, um, we're going to need more than George and we, they're very helpful at K3LR,
Yeah.
but I think that like many people, they really do not understand the mechanism for receive RFI injection.
Well, I think what we're finding is that what we are paying attention to now is fundamentally different from what amateur radio operators typically have to deal with at all. Most amateurs, like K3LR is a great example. He's a contest station. He cares about 160 meters, 80 meters, 40 meters, 20 meters, 15 meters, and 10 meters. That is what he cares about. And he cares about that during CQ Worldwide and the ARRLDX contests, and it may be a couple other major contests. But those are very narrow bandwidths. So now all of a sudden we're looking at a full 30 megahertz of spectrum and trying to go all the way down into VLF and do all this stuff. It's way more complicated than any traditional amateur radio station that's only caring about the contest bands would care about. So
Yeah.
it's a totally different experience trying to engineer for this.
Yeah, yeah. It'll be very interesting to see. In the end, it would be interesting to kind of compare what you would get. I'm not sure we can do that at K3LR,
Right.
but if you would have multiple triple eights connected to his big antennas and compare it with what we get with the single monopole down on the ground. I would expect there wouldn't be a whole lot of difference, actually. There'd be some, because of the gain and the low angle of reception. But I suspect that the difference, if we can get the monopole working well, I think the difference in its sensitivity between those of the big antennas is, for receiver purposes, of course, is probably relatively small.
Mm-hmm.
But it would be great to be able to test that at some point. And Tim and the group there seem to be interested in this. So
Yeah.
you build up as many triple eights, and you could put them out there for. They seem to be off air for extended periods of time. So
Yes.
seems like there's extended periods of time when we could actually do
Yeah.
some
Well,
experiments with
as
the
I
big
said,
antennas.
from talking with Tim, they really just care about these few major contest weekends. And
Yeah.
the rest of the time, there's a guy in Pittsburgh who remotes in who operates 6 meters.
Yeah, yeah. Well, that means that it could be we could learn some interesting things.
Yeah.
About that might be generally of interest to the larger ham community. It's just okay. You're having trouble with receiving people. You might be better off with an RSC on the ground properly installed than you are trying to fight the RF ingress that comes from your tri-band at 60 feet. I don't know. I mean, it might, it would be an interesting study. That I've kind of always look for ways that we could, relate what we're doing to the larger ham community. I mean, we're, we're in our little world and we have what's interesting us, but it would be nice to show the larger community what's the value of what we're doing for what they're interested in. So
Right.
anyway, that would be nice, but that was so George is taking that over, and hopefully we'll. But you or Majid will get an email tomorrow morning, I suspect, saying pack up a 888 and it's
Yeah,
capable.
well,
Send it off.
we can get one sent out quickly. So
Yeah. Okay, uh that's it for me. I'll send it back to you guys for general discussions. And we haven't heard, by the way, Scott, haven't heard from Dave Schwartz, so I don't know what's going on at WWV. Nothing has changed.
Okay. Did we miss anybody? You said Phil was in traveling, so so at this point we're open for general discussion.
Oh.
if there is no other general discussion topic, I might show this. I'd be interested in showing Dave Witten what we saw with this magnetometer in the lab today.
Yes, I'd be interested to see this.
Okay. I don't know that this, I don't know if this is a real problem or if this is just a problem with our particular board. We haven't done enough poking around yet to really know how much of a problem this actually is. But here we go. Let me get this on the screen here.
Is this a Raspberry Pi attached one, or?
Yeah, so and we are going to be migrating over to a Pi eliminator one. So that's why I don't want to be too alarmed, but here's a video. So what you can see here is that it's taking measurements every second. So here's 31. Oh, that's interesting. It's actually showing double measurements here. So 33.
Oh,
Have you seen this before?
yes, I have.
Oh, you have. And then the
Yes,
other
I have.
look at this too. So the X value is always minus 5663.2851, and it's always the exact same number. And then when she restarted the Pi, it went back to normal.
Okay, how do you start the software to run this?
I run a cron job. I have a cron job that runs a bash script that calls your run mag program every time we start up.
Okay. What's happening here is I'll bet if you did a PS,
Yeah.
you'd find that there's two instances running.
Mm.
And what's happening is that it's reading twice
Okay.
on every interval. And because one instance blocks, either it can't respond fast enough or it I can't remember what the deal is, but I've definitely seen this before. And so what's happening is two copies are kind of competing for the um
access to the magnetometer.
Yep.
Okay.
And um I did not write it in such a way that it would only run one instance. And that may be, yeah, you've downloaded the code from the source and built it. So
yeah,
that should be. I don't remember if I did something to try and prevent that from happening, or there's just something in the setup that causes that, makes it so it can happen. And
okay.
but try doing a PS AEF or whatever
Yeah.
pipe run mag, grep run mag, and see if there aren't two copies of it running out there. And then when you restart it, it doesn't do that. And so it's probably in how that cron job starts up or yeah, we have that's very good. I
You
didn't
know
I
what?
didn't know what to say about this, but
Yeah.
that all of a sudden when I see it, that's
You know
very
what's
familiar.
possible? They seem to notice it when they come into the lab. And I bet what happens is that when they come into the lab, because this started, like we looked at the log today, it started at like 1951 UTC, and it was all fine before that. And so it happened after they came to the lab. I bet at some point they sat down and one of them ran the run mag command at the terminal after it was already running.
I suspect something exactly like that.
And that would explain this.
Yeah.
Okay.
I couldn't even think of a good explanation for for
But
anything happening.
that would explain why they see
This
it
does.
after they come into the lab at some point. So it's all like
Yep.
normal. Then they come in the lab and then it starts doing this, because if it's already running the process in the background, then they come in, wake the computer up. It's already running, but wake it up, and then they decide, oh, we're going to actually run the run mag command from the terminal instead of just using the one that's already running in the background. That would create a second copy that would do
And
this.
what are you doing here? You're showing me the content of a log file, or
yeah, and it's actually a movie, so you can see it there. It's scrolling.
Okay, I do. Okay, I see. Yeah, sure. Yeah, it's trying to read the the X value at least twice. The Y it's not getting much. Every other time it doesn't get anything. And yeah, there's just one instance running and one and we know that trick. Yeah, and especially because I believe it's running as a background task, so you don't really see it in real time.
Right.
Yeah,
that
makes they don't realize.
That makes a lot of sense.
Mm-hmm.
Yeah, no, I think that probably answers it. And so you can see here they have they're now driving this oscilloscope with the square wave, and you don't see it on this video, but they have the Helmholtz coils set up. And I I told them to start trying to get the magnetometer to record a wave that has like either a 100 nanotesla or 200 nanotesla peak to peak signal. And I said that would be similar to what you might expect to receive a geophysical signal for some sort of a space weather event. So,
Sure.
and so they did when we did after she restarted it, then we were just getting normal readings, and we could actually see we got the numbers to change in a way that was synchronized with what the oscilloscope was showing. So that was
Sure.
good. Did you I can't remember. I think you might have you or anyone else developed a real-time plotting utility for this?
Oh, I don't think I've got one at the moment that's functional, but I've certainly worked on it several times.
Well,
And it's not probably the most difficult thing in the world to do.
no, well,
The
because
hard
I have,
part's deciding what language to do it in.
yeah, so I just got an email from a computer science student who said, hi, I'm a junior computer science student, and I'm friends with some of the other students who've worked on your projects. I was wondering if you have anything to do for research. So
Ah,
one possibility I was going to say is here we'd love a real-time display for this. And what I was going to suggest is to have the student build it in some sort of a web language so that it's served over a web server, kind of like the web SDR. And that way, anyone could log into it remotely and watch these things in real time.
I think that's a good idea. Use WebSockets or something and just spit those things or anything and spit them
Yeah.
out to a listener somewhere that then just plots them as they come in.
Yeah.
Yeah. And that's one reason I've wanted very badly to use that kind of format for the
Mm-hmm.
output along because it's very easy for most of the web languages to
Yeah.
parse, because there's a JSON parser in Python and in Node.js and in the browser itself, I believe, on the document
Mm-hmm.
object. Um, I believe that's where somewhere, navigator or document. So yeah, you just grab those things and then have it trigger an event that plots them and goes on to the next one. Yeah,
Yeah. So
good
that's what I'm
project.
thinking of. That's what I'm thinking of suggesting to the student.
Good project.
Okay. I will hopefully be
Yeah,
able to recruit a student who can work on this. Wish me luck.
good luck.
Thank you.
I'd love to see it.
Yeah, I would too. It'd be very nice. Great. Back to net. If there's still no other discussion, I want to highlight something else that we're doing here at Scranton.
Nathaniel, could I ask you a question? A quick.
Yeah, go for it.
So we, as we rebuild our club, something we talk about for particularly interested students is there are opportunities at Penn to do independent studies. So
Mm-hmm.
when I was in graduate school at UCLA, not Penn, I just did an independent study where I started a company for a year. And we also talk about for difficult projects, one of our students could do an independent study in amateur radio
Mm-hmm.
for a year. Do you guys, so when you say you have full-time people, do your students ever do a senior thesis or an independent
Oh,
study?
absolutely. We have a lot of that going on.
Right, right. Yeah, I was just curious because,
Yeah.
at the engineering school, they're not too primed in some of the entrepreneur activities. But yeah, all right, that's
Yeah.
interesting. That's something that,
Yeah.
and then you have a full-time student. He takes it on as a class, and he
Yeah.
can really bring into it.
Yeah, I've got a mix of things going on, so I'm not really doing anything entrepreneurial at the moment. But we do have so we have so the kind of the lowest bar is what we call the faculty student research program, where a student can sign up and just get transcript acknowledgement. There's no credit involved. It's just a line on their transcript saying they did, research with a faculty member for a semester. and the commitment level is 15 hours for a semester, which is like nothing. Then kind of the next level is there's some honors programs. We have a Magi's honors program in STEM where students are required, to work with a research mentor, and at the end of their 4 years, they write a thesis. So I've had some very successful students with that. Our physics majors are required to take some research seminar classes, which is basically just like a research class, and then they have to write undergraduate theses. I've also been able to fund a number of summer REU type experiences with grants where I've gotten students, I pay them during the summer. And then during the academic year, I keep them on the project. I don't pay them, but we do one of those other options like the transcript acknowledgement or a credit for, either a thesis or one of these independent studies.
Adrian, and where did that grant come from that you pay them over the summers?
I have some National Science Foundation and some NASA funding.
Gotcha. Right, because we lost our student club status, but when we did have student club status at Penn, we were getting 10 grand a year in the 19. So
Wow.
there's money, yeah, exactly. So we'd like to get some of our funding back, get some of our time back. Thank you very much, Nathaniel.
You're welcome. So the other thing I wanted to point out, and you may also be interested in this, John, I'm a member of the local club I'm a member of is called the Murgas Amateur Radio Club, and that's based out of Wilkes-Barre, Pennsylvania. And this is the 50th anniversary of the Murgas Amateur Radio Club. And the Murgas Amateur Radio Club is named after Father Joseph Murgas, who was a priest, a Slavic priest who emigrated to Wilkes-Barre in the late 1800s. And in addition to being a Catholic priest, he was also an architect, a botanist, a painter, and a radio experimenter. And so he is credited, he has many patents, and he at one point built two 200-foot antenna towers made out of wood, one that was in Wilkes-Barre and the other one that was located in Scranton, 20 miles north of Wilkes-Barre. And he's credited with having the first overland wireless communication. So before 1905, the Marconi company was able to do long distance communications over the water, but they didn't really have anything going over land. And so Father Murgas was able to demonstrate that yes, you could in fact have effective wireless communications over land. And he did that by transmitting from Wilkes-Barre to Scranton. And so we're recreating that transmission on November 15th at 1 p.m. We're going to have a historical reenactment of what happened 120 years ago. And in the original transmission 120 years ago, the mayor of Wilkes-Barre sent greetings to the mayor of Scranton and vice versa. And so we are going to have the mayors of Wilkes-Barre and the mayors of Scranton today be at this event, along with the presidents of both King's College in Wilkes-Barre and the University of Scranton. And we're going to have a whole big thing. And we also have a special exhibit in the Loyola Science Center again of different Father Murgas things. So if anyone is interested in this, I'm going to put this link in the chat as soon as I can find the chat. There's the chat up here. And make sure I send it to everyone. There you go. And so you can read more about this special event. And then right after the event, we're going to get on for November sweepstakes single sideband. So if you're in the area, please feel free to come on up to the University of Scranton and you can be part of this. And I think there will be something posted in the ARRL newsletter later this week. So we're very excited to be doing this.
And thank you very much, Nathaniel. I will jump back on the mic to say for Philadelphia and our region, I put together a Google Calendar that we're sharing amongst all of our clubs to have one place for me to see of all of our activities. So we had various different radio clubs in the neighborhood, like Williamsburg Radio Club, Philmont Radio Club, Mark, HamSCI making Zoom calls. So I just popped together a Google Calendar for myself where I put all the Mets and various activities on there. So I will share that on the chat. and it's primarily geared towards Philadelphia, but HamSCI is on there as well.
That's
And
great.
I just pop in general interest, and I will add this on November 15th at 1 p.m. contact. And it's
Thank
fairly
you.
self-explanatory, but my calendar has blue for normal nets, red for emergency nets, yellow for educational activities. So I'll pop that on the chat line, and anybody who wants to add to it is kind of a living, breathing document for our community. So I will share that with you all.
Thank you, John. That's wonderful. Back to net again. And thanks for the link to the book there, Clint.
I have a question, Nathaniel, about the metadata that's being captured for WWV broadcasts. Do you,
Okay.
right now, it's being uploaded to Personal Space Weather Station Data Repository as digital RF, and it contains the, obviously, it contains the 10 hertz wide signal around the carrier. But is there any other sort of timing or gap analysis that's included in the metadata for that?
I don't think there's definitely going to be, timing information. There's going to be timestamps on there. I don't remember exactly what's in all of that metadata. I don't think there's a gap analysis in that metadata, but you can certainly figure out the gaps by looking at the timestamps.
Yeah. Well, I'm thinking of a way perhaps to actually capture it in real time and be able to measure the variance minute to minute of what the differences between local system time and the RTP timestamp and then the WWV onset time
Yeah.
of the per minute signal. Or is that stuff that can be captured after the fact? I don't know.
I think that could be captured after the fact. I think something that we really need is we need some sort of better capturing of, is this WWV, is it WWVH, or is it something else? And I know you've worked on that problem before. I think the person who might have the most sophisticated knowledge of how to do that right now is probably Gwyn Griffiths. Have you talked to him at all about this?
I have briefly, in fact, when we were in Newark. But
Mhm.
you recall the problem that that Phil pointed out, which was that for whatever reason, maybe they didn't realize what was happening, but there's these intermodulation products produced at the transmitter
Mhm.
because one of the things that differentiates WWV and WWVH are 400 and
Right.
500 hertz tones that are broadcast on a per minute schedule. But
Mhm.
both stations transmit a constant 100 hertz tone that contains the digital timing signatures
Mhm.
and the intermodulation at the transmitter level will sometimes sum 100 plus 500 to produce noise at the 600 hertz level.
Yeah.
And subtract, both addition and subtraction will clobber the transmission from the other station. And what that does is it reduces by a large percentage the amount of time when you can reliably capture what you're sure is an independent transmission from one station or the other.
But Gwyn has a number of other, I think, thoughts on how you would disambiguate the two. And for instance, he'll look at a carrier and he'll say, well, this one has much more variance on the carrier than that one. And so it likely took a very different propagation path and went through different layers, or, and then he can say, well, based on what we know about where WWV is and where CHU is and where this particular receiver is and a number of other things, he can start to give you some sort of a probability. Well, it's more likely this one than that one. And these are, it's a little bit more of a sophisticated way of looking at it than just saying, okay, which frequency are we hearing? And and similarly, he might have different thoughts on how you could, you know, it might take one station longer for the time ticks to propagate from where they are to where the receiver is in another. And I wonder if we, had some sort of a discussion with Gwyn about how we might tackle the problem, even, despite the things that Phil pointed out.
Right. Well, I'll communicate with them. And part
Yeah.
of the reason I'm asking right now is because I was just writing this software right now to
Yeah.
try to capture some stuff, so that we didn't have to rely on Whisper Demon's project to do it, and we could excise that level of concern from what Rob has to worry about all the time. But in the meantime, see
Yeah.
if there's a way
So,
to capture stuff that isn't currently
yeah.
being captured. So
Right. But I would think any gap information, any timing gap information, why would you not be able to just get that from looking at the timestamps that are on digital RF?
yeah, you would be able to. I don't know that digital RF is actually capturing. Is it capturing the RF timestamps with the? Are they being stored in the digital RF?
You mean the ones that are recorded off the air?
Yeah.
No, they're not. So maybe that's
So
what you're saying.
you don't know what time zero is,
Right.
and so you don't know. Yeah. So there's potentially a gap between your system time and what the RTP timestamp is.
Yeah.
And then there's going to be a gap between either one or the other of those and when the uptick is on the minute tick on the
Yeah.
incoming WWV signal. Or separately WWVH signal, because WWVH broadcasts the minute tick at 1200 hertz and not 1000 hertz,
Yeah.
which
And
sometimes you can distinguish actually when you
Yeah.
look at the spectrogram.
Or another way to look at to consider the problem is, do we want to reconfigure how we're recording WWV to digital RF so that we, record a slice of record the time code as well. Maybe not all of this, maybe not all the spectrum between the carrier and the time code, but just have one slice that just pulls out the carrier, one slice that just pulls out the time code, and keep both of those.
Well, what I was proposing, or at least initially thinking about doing, was simply capturing precisely when that uptick is on the per minute tone, so that I've got a number. I don't necessarily have to capture all the packets. I just need to be confident that's when the top of the minute is according to the broadcast signal. And then I
Yeah.
can measure the difference between my local system time and when that uptick is, and between whatever difference there is between the RTP timestamp and my system time and that uptick is. And then I can put that in a CSV. I mean, it just,
Yeah.
1,440
And that'd be
entries
like
and
very
metadata in the digital
minimal,
RF.
very minimal additional data. Yeah,
Right.
I think it's something to look at.
But I will ask Gwyn too if there's anything
Yeah.
else we need to capture in
Yeah.
the data that might enhance his ability to do some of that other teasing apart you were talking about.
I think definitely explain to him what you're thinking of doing, and get his thoughts on it.
Yeah. Okay. I have this. These are the. This is 5 megahertz. Just this evening even, and you can see how the uptick is nice and clear.
Yeah.
And it's real sharp, but it's a half a second late. Late compared to what? Late compared to my system time, whatever that is. My system time could be inaccurate. But
I mean, now that might be interesting. Can NT, if you have GPS disciplined system time, and you're measuring that delay might be something that can help us disambiguate is a WWV or WWVH, right?
if we are, and this is something we haven't started doing yet, but we're talking about injecting a pulse per second, which would give us a much more accurate timing.
Right.
Just because it's discipline doesn't necessarily mean we've got time from the discipline, but I think the new Bodnar that you're going to be sending with Daisy has the proper PPS, and that would that would enable much more accurate timing, I think.
Yes, I
And
agree with
then,
that.
if the other thing we could conceivably consider is some ways to increase the accuracy of local system time. In other words, um,
Well, I think this is one of the things that Jonathan tries to do, and maybe Jonathan can speak to this, but he's been very insistent on making sure that his terminals for the VLF system have a hardware serial port. And the
Yeah.
reason for that is he's having his GPS interface give the pulse per second to the hardware serial port, and then you're able to accurately synchronize your system time to the GPS time.
Yeah. Well, if one way or another, I think we could probably do that with this as well,
Yes.
without too much difficulty, especially if we're talking about inserting that PPS.
And you're right, and that's one of our goals with inserting the PPS is to give us that reference that we need.
So there's probably a way to insert a PPS even before we get it done formally, so that we can at least get the math done here, so that the system records it. And then we'll have a closer to real-time baseline to compare the RTP stream, although the RTP stream should be syncing up with that. But then we'll have a better basis for determining what this real distance is, the real onset of that WWV uptick is from
Right.
real time, and
Right.
what the time of flight is. What's interesting to me is how it differs. Am I sharing the whole screen or am I sharing both? Can you see this one now?
I just see the one window with the 8 panels on it. 8
With
plots.
the 5 megahertz.
Oh yes, the 5 megahertz.
Let me share the 10. Oh, that's 5 again. So I beg your pardon. That's 5. Are you seeing 10 there now? No. Stop share. Sorry. Let me do. Is that 10? Okay. Is that 10? Yeah. So you see how the other one was a little bit after half a second onset. This is like about 0.3 seconds onset for the same signal at 10 megahertz as opposed to 5, only a few minutes apart in terms of the time that I measured it. So
they will. There's no consistency with this, Michael. The offsets are determined by the when the individual they're called LIN threads in Radio D, and it just depends on how they are scheduled by Linux, and in the timing measurements that Scott and I have done, the offsets are in PCM record are anywhere from 17 or 15 milliseconds to 60 plus milliseconds, but after that, after whatever the offset is, and the offsets differ from one band to the other. So you just it's indeterminate. It is constant but indeterminate. And the only solution is the one that Scott and I, or Scott and really Paul have come up with, and Phil, which is to inject a PPS signal into the head of the system, and then look for it in the demodulated stream. Now I see that Paul and others and I think even Tom has talked about this, is injecting a pair of values between the analog to digital converter and the FX3 when at the triggered by the PPS signal. So, there'd be a PPS signal that appears, and there'd be a little FPGA that would, replace two samples, one with a 0, one with, FFFF. And since that pair of signals are so unlikely to ever appear, in a normal data stream. That could be used by the Phil Carnes software to establish what that time zero, real time zero of the sample stream. But you're short of that. It's a guess. You can only guess at what the time offset is. It's in the under 100 milliseconds range, but it's not constant. So you'd have to look at every band individually to figure out what its offset is during this recording session. You restart Radio D, and the offsets all change.
Can I
Because
mention something?
Yeah, we need to come up with a better way of synchronizing things. Because
Well, that's
just so
that's
you
what
know,
we're doing.
Michael, the actual delay from Hawaii, I just figured out, Hawaii to New Hampshire is 27 milliseconds. So your things on orders of a second are artificial.
Yeah.
Well,
Well,
I have no doubt that they're artificial. I guess the question is how to get the baseline somewhere where you
Right.
want it. It was just occurring to me that, the appearance of that uptick is nice and sharp. I mean, you
It
could
is.
use that and then subtract the distance that is between here and
Right.
Hawaii or here
Well,
in Fort Collins.
theoretically, you could create your own, say, 10 megahertz or something on that order pulse.
That's
and
what we're
put
doing,
in
David.
another,
That's what
yeah.
we're doing. We're
Right.
doing that. Yeah.
and use, if you get the edges off of, put it in at a slightly different frequency and grab the edge from that.
Yeah.
But you're right. It's quite striking how sharp that edge is.
Can I mention something here that might help you, Michael?
Please. I need all the help I can get.
Well, Rob's exactly right that when the LIN threads start up, they will not start on the same, there's 20 millisecond framing there that you're going to run into. So you have a channel group for WWV, for instance, and your 5 may start 20 milliseconds after 10, and it may be 40 milliseconds after 20. You just don't know.
Okay.
But recent versions of Radio D do adjust the RTP timestamp to compensate for that.
Okay. Well, so those delays that you were seeing in that graphic, I mean, one of them was over half a second. That has to be some offset in my own system time, probably in the clock, right?
But your system time would be consistent across 5 to 10, right?
Between 5 and 10 megahertz.
He's got the
You
same
would think
system
so,
clock
and
for
it
both
was about
recordings.
0.3. It was about 0.3 seconds difference in terms of the two bands. Yeah, 0.3 of a second. One of them started just after 0.25, and one of them started after 0.5. The uptick.
That's far more offset and variance and offset that than I've ever seen with Scott's PCM record.
Yeah, I would expect if you were not taking into account the RTP timestamp that you would see a multiple of 20 milliseconds. But even if you had a lot of channels, there's no way Radio D is going to spread them over 300 milliseconds.
That fast.
Yeah.
Well, I have to look into that and see what the heck's going on then. That must be based on system time, but I'm not sure about, the difference between them. Yeah, it was almost 0.3 milliseconds, the difference between them. So
yeah, I can't see system
that's
time being an
pretty,
issue.
that's pretty large difference. Even if the system time is way off, you'd expect the variance between the two not to be not that great.
Exactly, yes.
All right. Well, I got something else to look into.
It's great that you're working on it. It's wonderful, but I think that if we can test the PPS signal generator that is on its way to WWV and Paul is redesigning, that will give us absolute time. We'll know exactly within, I don't know what the PPS value, what is PPS accuracy, 70 nanoseconds or something.
Yeah.
Well, it's not going to be that good because you do have to demodulate it.
Of course, yeah, I mean, that's right. You're demodulating it, so it's subject to the bandwidth um, of the signal that is generated. I don't know how Paul. We're sticking the signal up at some place, right? It's up at 60 or 80 megahertz.
Yeah, 84, I think, aliasing down.
Yeah. So it can be pretty
The
wide
hardware is better
bandwidth.
than software.
Yeah.
I
So
saw
it doesn't help to actually get your system perfectly synced. It wouldn't help to get that perfectly synced because of what you say the processing problem is here. You actually have to sync the incoming RF streams. That's what you actually have to sync on the PPS.
That's what that's what the signal that's being generated will do. Scott's software
Yeah.
looks for a PPS triggered RF signal that's introduced into the input of the 888. So there's at 80 megahertz there's this PPS signal, a modulated signal, BPSK modulated signal at 80 megahertz.
Okay.
And it's modulated by the PPS trigger. So the receive software tunes to that frequency, demodulates it, and looks for the rising or the transitions, and the accuracy, and since those transitions are generated by the GPS receiver, PPS output, you know that the sample time relates to the GPS second time.
How do you know how do you sync them in terms of number?
Well, you look at what's it called, NEBS time. So you know that what second you're in, right? Because it tells you what the time is. The GPS uh, thing tells you what time it is in RS-232 data stream. So you know that you're at second zero.
So you know which one of the ticks is second zero?
Yeah, I mean, obviously, if the whole thing were off by a second, then of course you'd be off. You could be off by a second, but we're talking
Okay.
about millisecond differences here.
Second zero is a different frequency.
Second zero is
It's a different frequency than regular time ticks.
Yeah, but this is a signal that we're generating. We're not looking at W. We're not. Yeah, this is not a signal generated by WWV.
Well, you could do the same thing.
Could do the same thing, but then you're subject to the SNR. Yeah, how good. So yeah, that works at WWZ0.
Now, on the other hand, if you can identify it in WWV and you find your locally generated tick next to it, then you also know.
Then you know the time of flight. That's the whole.
Yeah, but you also know which is your like top of the hour, top of the minute.
Yeah.
Because you're only going to be off by milliseconds.
Yeah. I mean, you're right. There's another layer
No
of
ambiguity there.
Yeah, it could reduce the ambiguity. So there's a way to do it, but I don't think in our experience, I don't think we've ever seen. I mean, we've been running. I haven't looked, to be honest, in a while, but we've been running this Scott's code, which looks at the rising edge of the 1 kilohertz tone, and documents how it varies. And I've got a log file that we could look at that shows you what that variance is. And whatever they are on each band, right? You look at that time offset. You start up radio D. You look at the time offset. It's 17 milliseconds on the 10 megahertz. It'll stay at 17 milliseconds for weeks. I mean, the whole system is very, very stable. It's just that 17, it'll be 17 milliseconds on the 10 megahertz WWV. It'll be 42 milliseconds on 15 megahertz. They have no relationship between them. The different bands, but they're within a band. The offsets are very constant. But you couldn't use it for time of flight. I mean, you just don't. You don't know how much
without
of that
pulse per second, then the rising edge is the best you can do, though, assuming that you don't start and restart well, actually, even if you do start and restart, it'll just sync back up again.
Yeah.
I think I'm going to say 73 for tonight. But
Yeah.
thank you very much, everyone.
Yeah, I mean, all
Well,
of this stuff is kind of waiting on Dave Schwartz to take the new equipment out to the receive site, WWV receive site, so that Scott and Paul and, to some extent a little bit, I can verify that this 80 megahertz BPSK tick signal works. I mean, Scott has had it working at his house, so he's a skip away. So I don't think there's any reason it won't work. And I think Paul is incorporating this into the design work he's been doing. This is part of a sidecar, and now maybe even a DV8 design that has the sidecar and
So
does
Scott,
the
what happens when the propagation is poor and you lose track of that uptick?
the tick is generated locally. It's not the tick
No,
is
not with the PPS. I mean, he's currently,
oh
you said he's currently measuring the upslope on
we
the
yeah
100,000 hertz tone.
yeah but we only do that at 6 kilometers from WWV transmit sites at the WWE receive site, and also we've had it running at Glenn's, which is 17 kilometers for WWV. Those sites is the only places where that looking for the one kilohertz tone has been utilized. I mean,
I'm running it locally.
you get it, right? You get it probably pretty well. It just
When the propagation's bad, my numbers don't make sense.
yeah.
Yeah.
So yeah, so you lose. I mean, you
But
could
theoretically, when the propagation comes back, it should sync back up, right, Scott?
Yes.
it should appear
Yeah.
right back up if given that there's been no time sample slips in your system.
Right.
The WW can go away, it'll come back, and you should see it at the same 17 milliseconds offset.
All right. So this is helpful to me, though, because I mean, I was originally thinking about the variance between system time and the uptick. But what's more important is the variance between uptick in 1 minute and the next, and the next, and the next, and
Yes,
on the same stream.
well, that's it.
And
I
that,
think yeah.
okay.
Yeah,
That clarifies things for me.
yeah, and that's one of the reasons why it's key that you make every recording, exactly the same number of samples, right? If the sample, if you drop samples, right, then the ticks times are going to move even,
Right.
and so and you've lost all calibration. So you really need to, be
Count samples.
sampling
Yeah.
960,000 samples, and then go to the next wave file and look for the time offset in the next wave file. And and if they're not, if they're not the same, then you've got a system, a loss of data in the receive system.
Yep.
And that's about the only way we can detect it right now, because we can't really detect. We have no insights into USB transmission errors. They just don't get propagated up to the driver levels. That's my
All right.
understanding, at least. This is we're not talking about stuff Franco does. I don't. But my understanding is so so we ran for weeks. We ran, and we're still running it. I just never look at the log files, but we're running at WWV receive. We see this very constant offset. So you could use it. I mean, you could just say, we know where that tick is. That sample is times 0, and then you can adjust your wave file recordings to compensate for that.
Right.
but as you know, it becomes fairly complicated. You decide, oh, okay, I'm, 30,000 samples into this wave file is the actual times zero. Oh, now I need to go and add in 30,000 samples at the end from the next wave file. So each subsequent wave files, you have to kind of glob them together in order to get them time aligned.
Michael, on the graphs that you were showing us earlier, and we were talking about this 300 milliseconds trying to account for it, are those graphs correlated in the x-axis? Is that from the system clock or from the RTP timestamp?
System
Okay.
right now.
If you were to use the RTP timestamp, that might be interesting to see if that still exists.
Yeah, I will add that. I'm going to just sort of rethink how I'm calibrating the whole thing, actually, because I hadn't been doing it that way. But I'm going to use the RTP timestamp should be a strict count, right?
It is
From
the number of
minute to minute.
samples. It's the
Yeah.
number of samples at whatever your sample
So
rate for the demodulator is.
so
So
that's exactly,
timestamp's kind of a misnomer, but a sample count is what it really is.
there you go. Yeah. So whatever time that corresponds to, at least we know it's the number of samples in a minute. So
Yeah, so you could
um,
record one channel, correlate your timestamp and the system clock, and then plot based on the timestamp. And
exactly.
there is another feature of Radio D that I'm not very familiar with, and Phil's called it Time Snap, SNAP. And I think that
Is that
is,
snap or something? That's
I
something
think
different.
I think it is the system time when that demodulator block ran the inverse FFT. And I believe it's consistent across all channels.
Mm.
So instead of using
Okay.
the system clock of when the packet arrives at your Python program, you could
Right.
take the time stamp and the time snap and compare them.
All right. I'll look in this code and see what
Um,
he's doing with that.
Yeah,
Good
I think
idea.
there's something in PCM record.
Okay. Cool. Thank you,
That
guys. It's very helpful.
Well, thank you for working on it. It's just it's a kind of a hard problem. I think that it's really, if you can, the ultimate goal is for the recording program, PCM recorder, to detect the absolute time of the sample, time zero sample in the incoming data stream, and then create wave files where the first sample of the wave file is that rising edge uh, of the time tick signal. And then you don't have this slopping around to figure out, oh, okay, what is the offset in this one? Well, then I have to add on samples at the end because every,
Right.
but what Scott has now, and it's what I still have to use, is his version of PCM record, which does that because Phil's doesn't. Phil's goals for PCM record are different, and he tries to do error concealment and so on, and that just scrambles the data stream
Well,
for
in
our
that regard,
purposes.
Rob, though, how are we, the only way we're recording that we've lost data is the fact that there's a dummy file inserted into the data stream, correct?
No, there are two ways we detect it. Okay.
No, not detect it, but keep a record of it.
Oh, we keep a record of it. Yeah, in
So that,
essence, yeah. If you wanted to look if you wanted to look at the PSWS site, and you could see that if there's a time slip, if there's a data loss, USB data loss or other sample loss, um, which slips the wave file timing off of its constant, then what would happen is eventually, this is the limits of what we could do now. Eventually, the end of a packet and the beginning of the next wave file would slip out of second zero and into second one or second two. At which point, PCM record says, I'm not recording anymore. I'm going to resync. So it drops the recording the WAV file. And at which
For a
point,
minute.
until the beginning of the next minute. Yes.
Right.
The second transition. So the result of that is that the Whisper Daemon will say, whoops, there wasn't a WAV file in this minute. And eventually, when it prepares to do the decimation and uploading, it substitutes the silence file for that missing minute.
So
And
that's the record would be, that's what I said before, the record would be the presence of that silence file in the data stream.
yeah, it's I don't know. I don't know how it would appear in the 10 hertz output that is uploaded to the PSWS server. I mean, it's
Well, what I'm
presumably you
talking
get a
about,
minute long would show of 10 hertz would show up as being a minute of 10 hertz silence. It's really obvious, okay, in Whisper Daemon, of course, it's really obvious that it's a
because you lose a whole minute. I mean, you lose a cycle.
there's a cycle, and you can see there's a fix up routine that Whisper Daemon does before it uploads. It goes through and validates every minute of the previous day's recordings, and any minutes that are missing or they're corrupted for any reason where it can't. They're stored in a compressed format. So if it can't successfully decompress a minute, it marks that as a bad minute and substitutes. I haven't documented whether that ever occurs. I don't know that.
Theoretically, though, what I'm getting at is if we're running along here in real time, we could probably get away with not losing a whole minute, but losing a few packets, but keep a record along the way for each minute, just a CSV file of whether you'd lost, which were the packets that were, did you desync it at the beginning or desync it at the end? And instead of inserting a dummy for a whole minute, insert one for 1 or 2 packets. And that way you get back in sync with the, you save those
Absolutely,
minutes.
be my guest. Okay, yes, there's you could go absolutely. You could do a better job of error handling, if you wanted to invest time in it. And I just went as far as I could with doing this all in Bash. And when I eventually you or I get to rewriting this part of the Whisper Daemon client, you can do a better job of error handling. Unfortunately, this whole thing ends up devolving to you don't really know what you can't. The only way you can identify that there have been lost samples in the between the A to D input and the buffer memory, right, where the USB samples driver puts it. The only way you can really determine if there's lost packets, my understanding, is if you look at the system time at the end of 960,000 samples, look at the system time, and it sure ought to be second 0. It really ought to be millisecond 17. I mean, if the last one was 17, this one should be 17. So that's
I got that part of it. I'm just thinking about
Yeah.
filling in gaps rather than leaving bigger
Yeah.
ones. But and then once we get pulse per second, it'll be even more reliable. But okay.
Well, it's error handling is 90% of programming. This kind of stuff is how do you deal with errors? And
Well, not only deal with them, but deal with them. Not only recognizing them, but also documenting them so that so that somebody going back knows, oh, here's where there was a glitch.
There's
And,
yeah.
Here's where there was some, there's some fill here, which is not real data that gets things back in sync and whatnot.
Okay. Yeah.
Well,
Well,
if you're really interested in that, Michael, you should look at Phil's PCM record code.
That's what I'm about to do.
He has a resequencing queue. He can deal with packets arriving out of order and put them back in order. And I didn't understand it and didn't want to spend the time to try and figure it out. So that's why I don't use it.
That's in PCM record that he wrote?
Yes.
Yeah.
Okay.
Yeah.
Is that where you said he had the time snap thing?
I believe it is.
Okay, I'll look in there.
I haven't been into this for about a month, so I'm a little vague and, confused here. So don't take me at
Well,
my
that's
word.
my permanent state of mind. So I'm perfectly at home with that. So,
well, but I think
all right.
with the help of AI, you could probably do, generate, do a lot more to, I mean, I would, I'm thinking about doing this for parts of Whisper Demon is to just take some subsystems, take PCM record and give it to Claude and say, hey, translate this into Python. And by the way, you should look for this and, tell it all the things you want it to do. Oh, look for the first rising edge on this and use that to begin the sample streams and check all this stuff. There's all this stuff. That's how I would do it. I wouldn't. I'm no longer would try to code this kind of stuff. It was mind bending for me to work in this area of the code. It was just it really gave me headaches, and it works the way it works very reliably with the caveat that we don't really know exactly what you know, I mean, they're clearly our samples. We do nothing. I do nothing to compensate for the offset that is clearly there in every WAV file. So everything that's uploaded by Whisper Daemon to the PSWS has some offset. It's beginning before the top of a minute, the beginning of every WAV file. Okay, in the order of 17 milliseconds to 60 or 70 milliseconds is what I've seen there. That's true of the recordings we have now.
Yeah.
Could it be?
That's just a built-in function of the fact that we're using processor that has to do things in sequence, right? So that there's no getting around that.
Well,
So,
it comes ultimately from the way Phil Lin programs. Maybe maybe he's doing something in his linear demodulators to trigger off of the system clocks. Bill seems very suspicious of the accuracy of the system clock. In my experience, even up at VY0, where the NTP connectivity is poor, the offset and jitters are in the at most 10, 20 milliseconds. NTP is pretty good at keeping the system clock in pretty good sync. So I think that Phil could use that. I don't know what triggers his Lin decodes right now. I thought that the sample that maybe you know this, Scott. Does the FFT output have a timestamp associated with it, a system clock timestamp associated with the I mean, you're getting a block of FFTs, right? Every 20 milliseconds, is it? Or is it
I,
50?
I think that is what this time snap is. I just did
Yeah.
a grep on the source code and I lied to you. It is not in PCM record, but it is part of the status stream that you're receiving.
Mm-hmm.
And
okay.
his comment is snapshot of current real-time protocol timestamp for linking RTP timestamps to clock time via GPS time.
Okay.
Well, that'd be great. That certainly would be, to propagate his notion that, his idea of what time it is, clock
Yeah.
time
I'm going to
associated
look
with the
into
stream.
it so I see if I can understand it and how whatever he's trying to implement at his level that I can do this, take advantage of it in the recording and documenting level. So
Yeah, you'll have to interpolate
at the
because
other end of the RTP stream.
I think by default it's running at 2 hertz on the status stream. So you're only looking at a time snap, every 0.5 seconds.
Okay. Well, you don't need it every. That must be a good guess, I suppose. I wonder what the optimum time is. Depends upon what your tolerance is for variation, I suppose. But okay, lots to chew on.
You're into some of the hardest part of the whole system. Core of this stuff is getting, understanding what time each sample was created. And
Yeah. So what I'm finding is that he anchors the RTP timestamps to UTC wall clock time. And then he's got a packet resequencing, 64 entry circular buffer, sorts the packets by sequence number. Timestamp based gap detection. Okay. Basically, he's putting a lot of trust in the RTP timestamp, that's for sure. And then the up the rising edge of the WWV tone can be the anchor for the time snap.
Yeah. Yeah, instead as a refinement of the system clock time.
Yeah.
Refine
exactly.
it using the rising edge of that, and then you know when the first sample should be recorded to the WAV file. That would be a real helpful. If you could write this as a standalone, okay, Python program that outputs that you give it the well, of course, you see PCM record listens to all of them, right? Gets every stream out of the RTP multicast stream. So there's one PCM record instance for all, 15, 16 whisper channels. So it's actually listening to one multicast stream and creating from it 16 different wave files simultaneously. And of course so the offsets will be different. So you have to introduce a different RTP, you have to treat them all individually, their offsets.
Yeah. Okay. I got work to do.
Yeah. But anyway, if you were to come up with a Python routine that behaves like Scott's PCM record,
record.
but with this further refinement, I could incorporate it immediately into Whisper Daemon.
Okay.
So, by the way, we don't have many people interested in this, but I did check in new code today that specifies Phil's latest commit and the web. What's his name's web code version 2.77.
J92 web.
Yeah, no, yeah. QWeb is his version, Wayne's version 2.77, which is the last thing he checked in. I guess it was October 31st or something. And Phil's check-in was from Saturday. So I meant to go and look and see if Phil's check-ins included the Scott's revision, the watchdog for the FX3 watchdog code. There's an image file
That's been there for some time.
Okay, well, so that means that I may not check for that difference. So, and when I try to do in Whisperding when you start it up, I try to go through and look and validate everything, but I don't necessarily know everything that needs to be validated. So it looks like that's probably something I should. You could just force it by, of course, deleting the and recreating file. Do a make install, but I can't once you put your code into Scott's code PCM record. I build it in Phil's directory. So once I do that, I can't really do a make install there anymore. So anyway, it's.
Can I ask a different kind of question just to prove the very depths of my ignorance? Not on this topic. I was thinking of it more related to the WWVH, WWV discrimination thing. I just happened to read kind of a commercial blurb talking about the possibility about audio. I think they were talking the audio domain, but using AI to de-stem, not terminology I really knew, but to de-stem like music tracks, which I took to mean really to kind of to separate like the bass track, the drum track, the vocals into different components. And I'd never heard this term de-stemming, but it's kind of the opposite of, you know,
Mixing
dubbing,
or
mixing. Yeah.
dubbing.
Yeah. And it may be that it's more possible with the lesser time constraints of the audio world, and it may just confound anything you're doing here, but still it just caught my eye. Does anyone know anything about what they're talking about beyond that? So I thought there were some folks who had some audio background.
I'm so out of audio, I couldn't be helpful.
Okay, I'd never even heard that term, and I had to read the whole thing just to find out what stems were.
What are stems?
It sounds like they're the tracks that the tracks like the drum track and the vocals track that you mix when you're putting together, you know, in the old days of multi-track audio recording. But undoing it using AI algorithms, and so being able to remix things for commercial purposes.
Demix.
Yeah.
Demix or that's a fascinating
But
idea.
it just seemed to have, if there were some tricks there of interest, it might have some application to the problem of WWVH versus, discriminating nearly very similar signals. But
yeah.
But I don't know. Just want to prove how little I know about some things, if I haven't already done that thoroughly by now.
I think some of us are way ahead of you, Dave.
No.
In demonstrating that.
How
to get over your head in 3 easy steps.
Deep waters, but
yes. Anyway, I'm gonna retire, gentlemen. Thank you very much. It's been very educational.
Good night.
Food for thought.
Good night, Michael. Take care.
Peace.
Clint, you still up for putting on a ticker if the WWV0 is not going to pan out?
It just needs to be plugged in. I mean, that's it's as simple as that. It just actually that's not quite true. We patched it out of the signal path on the 888, but it could be but we could reinsert it mainly because it was the combiner. We used a splitter to combine the two signals. Is that right? Or whatever we used had a low frequency cutoff that was impacting the 2200 meter and maybe 630 meter reception on the 888 up there, but it could be put back in.
As long as it doesn't cause a problem, obviously.
Right, and they're also on. Also, the current frequencies are all in the individual ham bands. They're not. They're what 500? No, they're 1 kilohertz above whatever.
Oh yes.
The existing bands, but I mean, if you're going to pick up something off the air, that would be a worthwhile test to see how. We could also reprogram them, I guess, and I could even build another one, I suppose. Just a single channel one would be trivial to build. We could,
Well, you had mentioned using a prog rock.
yeah, that's what they use.
Yeah, because it doesn't need to be GPS disciplined.
Oh no, it's, you know, if I mean, if it needs to be, then we're doing it wrong.
Exactly. It does not.
Right.
That was just an easy and convenient way to get the first prototype out.
Right. Yeah. Let's see here. I could. Yeah. I mean, that could be done easily. Yeah. It's literally the we have a Symmetricom GPS DO up there that will that it provides the reference for the prog rocks are actually locked to 10 meg ultimately. So we know what frequency they are within a few millihertz, or at least. So, and once they're up, so they're actually locked. If we plug in the GPS DO, they're actually nailed down in frequency.
If we were to do that, is there anything you need from me?
No, other than maybe.
Perfect.
Well, other than maybe, unless if you don't want to deal with them in the middle of a ham band, I'd just have to tune them somewhere else.
That'd be your call.
Right, but it might almost be easy enough to build a simple standalone box that would just stick a prog rock in a simple modulator and use it and slave it off the existing box would build, rather than cluttering up the well, I don't know that it would really bother anybody, because no human actually looks at the 888 receivers anyway.
Yeah. Clint, I'm about to.
Oh, okay.
Did you want some of these?
Yeah, just a pair of them to analyze them, to check.
Okay, I found I have 6 of them. I think
Oh.
I pulled some out of KFS because they were doing no good. They didn't make any difference. They were going to the Kiwis.
Right. I mean, yeah. Yeah,
So
I mean, yeah, we solved our Kiwi interference problem by moving our 2-meter receive antenna 150 feet farther away.
Okay.
I mean,
Okay.
that is what it took. Plus,
Yeah.
we have a building full of computers, and we have originally the 2-meter antenna was on the building, but we since have moved it out to the closest tower 150-ish feet away, and pointing in a different direction and up, 40 feet or something.
Okay. Well, I don't know if you noticed, we had a power outage out of KFS last week, and which led to a whole frantic day of working with Phil, berating me for having messing with his code. I did uncover some problems in Whisper Daemon where I misunderstood how he was using his services, and I was shutting down one of his services. So
Oh, I didn't know there was. So did the UPS run out, or?
I don't know. Nobody tells me what happens out there. I don't,
Let me check the uptime of the server, because I wasn't aware that anything had failed.
Well, all of the rack, the SDR rack, I think all the servers went down. I don't know about the Kiwis. It could have been one of these short-term glitches, which um,
Let's see if I can remember how to log into it. Okay. There it is. Well, okay, the web SDR has been up for 257 days.
Okay, so it was a short-term glitch that maybe affected only uh, the the B links.
Well, without a
Hmm.
capacitor or something,
Yeah, well, that's
they don't, they don't hold up.
yeah, well, that's what I was. There is let's see, I'm just trying to figure. I haven't been out there for 6 months at least, and so I've been waiting to go out, kind of waiting to take WD2 out there, but uh, I think it's going. That means yeah, I wouldn't go to KFS for another month. I don't know. I don't. As long as it's working, I don't see nobody's pressing me. I did get went to my friend's house down by Santa Cruz on Saturday, and they were having uh, parks on the air at this park that's a block up the road from him. And I mentioned to the hams that were there that I was on, that I was, the point, the support person for KFS, and they got very excited. And they want me to give a talk now to
Well,
their club.
just do it on the condition that somebody will help put out a 501c3.
Yeah, that's yeah, it would be. Well, I think that maybe I'm hoping that this Brian, who's also a POTA person,
Is he the one that visited you?
I met him at the Pacificon, and he's the one who's using your
Oh,
site for the POTA database.
The soda mate guy. Okay.
Yeah. So he's. I'm hoping that he will express interest and in working on this.
Well, I mean, the other thing we could do is we could put a notice on KFS, carefully worded, soliciting support for a club with 501c3.
Yeah.
Or an organization, or help with setting up a 501c3 in California. I mean, we could carefully word it, because I mean, you don't want to be a freak magnet, if you know what I mean. But
yeah, I know.
then again, unless you ask, nobody's going to know that need
Yeah.
that.
Well, I'm reaching out, visiting the local ham clubs on this side of the hill. The Half Moon Bay people didn't want to do it, so Half Moon Bay Club. So Brian Soda, whatever it is,
Soda mate, MAT with a little with a what is it, flat A, a long A, or
okay. Anyway, he's seems like a great candidate. That's why I wanted him to invest a little time in doing the coding changes to support his FT8 format. Then he'd have a little skin in the game. And
now, how would that be done? Because I presume right now he's simply setting up an audio stream and parking.
yes, yeah. What we could, if we just modify the FT8 decoder that Phil uses. And right now, apparently, it filters out, it only forwards uh, uh, spot reports or lines for a certain class of FT8 messages. And there's some kind of a field that determines what type of message it is. And this is, I don't know, I don't know that, but anyway, he said that it appears that the decoder that's in use filters out and drops other message types, and he's using a different message type. And he said that Phil Gladstone said that if he delivered these soda messages, that Phil Gladstone would record them and make them available.
Okay.
So I said, okay, well then it sounds like all you need to do is modify that code. I gave him a link to the FT8 library. He knew it. He's using it in a little product thing that he's developed. So I thought, well, you're the perfect person to modify this thing, and give it to me, and I'll stick it in Whisper Demon, and you'll get your messages from all it, not just from you're from Utah, but from everywhere. So I thought I gave him lots of incentive to work on it.
Yeah, he hasn't contacted me as far as I know.
I know. I thought that was a little. I said, I told him. I said, you're. Clint is wondering what people, if these malicious use, it would be good of you to tell him.
So I did see. So a couple months ago, I did see some leech streams continuously, and they were the name on them was the JWSSC stream. So I googled that, and we reverse looked up the address that it was using, and it came out somewhere in like Finland or something like that. We couldn't figure anything out, so I had Brett block them. Well, a few days later, somebody sent me an email saying that they were actually showing up as live feeds on live YouTube streams, and also he was also doing it KFS and at KPH. So he was actually glomming onto the Kiwi streams as well, 24/7 in some cases.
Yeah.
So I sent him a polite letter, but kind of sternly reminding him that we don't mind people doing this, but we don't mind you. We don't necessarily mind you doing this if you let us know what you're doing. But one thing we do not want to do is we do not want people monetizing this and shortchanging all the people who donate and support these things.
Yeah, yeah.
And I never got a reply to my email. I made it clear that talk to us so we can come to do something. But I don't know. And also I pointed out that we did try to look up by the name, and you didn't make it easy to find it.
Yeah.
If you were really on the up and up, you would have named it something, something Googleable.
Yeah. Well.
So anyway.
It's interesting to me. I told him that I thought you'd be happy to have him do it.
Oh yeah, I knew about Sodamate because there's a podcast called I think Workbench, Ham Radio Workbench, and that guy Brian or whatever his name is was actually interviewed. Let's see, radio work. Let's see, let's just find out. Workbench. Sodamate. Let's see here. Where is it? Oh yeah, January of last year, episode 199. So if you're bored one of these days or want to get to sleep, then I'll put the link here. Let's see here. There it is. But anyway, that's the Apple. It's a version on the Apple. Yeah, Brian. Alpha Bravo 6 Delta.
Yeah. That's it. Well, he seemed very excited. He did say he was very busy right now with projects, and that it would be a month or two before might be able to turn some attention to this. So I said that's okay. I mean,
yeah, I have no problem with that sort of thing. As long as it's on the up and up. Something like that. And it sounds to me Sodamate is it's free, plus it's kind of a clever idea. Although it struck me when I heard it described, you could, if you squint at it the wrong way, it could run afoul of Part 97, and because you could almost claim that it was intended to obscure the meaning of the communications.
Oh,
But yeah, but then again, the FCC has been very liberal about that recently. For example, um, what is it? Oh, it's the oh it's the thing that's on HF. Uh,
oh, those the high-speed traders.
no. It's in the ham bands.
Oh,
There's the Vera, VARA, Vera. That is actually encrypted in some way. And also the same thing with Clover was and a few of these other proprietary modes. But the
ah,
FCC has kind of said, well, if you can go out and buy the program that decodes it, then it's fine, even if it is, nominally encrypted. And nominally encrypted could mean there's a fixed key or just non-public
yeah,
modulation and coding scheme.
yeah,
And that's Vera, I understand, kind of falls into that category, sort of. But
yeah,
there are some proprietary ham radio modes out there, D-Star, the codec, that
yeah,
the FCC kind of said, as long as you can buy the thingy that does it, we don't care. As long,
yeah,
so
yeah. Well, I don't know anything about those monitoring of.
right.
I guess there's FCC people out there supposed to be monitoring.
I
But
I know someone who used to do that, but then he was informed by email when they redid it that his services no longer be required, and
mm.
I don't, and they're very mum about who it is or what it is or something like that, and so
Well, I went to the Palo Alto Radio Club, and there was a presentation from a retired head of the monitoring bureau.
right.
Gave a talk, and all I could think of through this was, at this point, what is it? 90% of the communications are digital. We've got a database that has everything. Every FTA 8 and 4 transmission received across the country is being pumped into the PSK reporter and scraped into a database. On our WD1 server, Andrew has a scrape of the PSK reporter, which of course dwarfs the database for Whisper.
Right.
Yeah. But even so, we've got plenty of space for it. So you can go in there and query our database and find out who's, look for people who you could write a program to query the Andrews database, ClickHouse database, and find people who are doing things that they shouldn't be.
Well, yeah, but yeah.
But I wouldn't. But that's not something I'm interested in.
Well, yeah, but people misbehaving on FT8 is probably fairly rare compared to other things happening.
Yeah.
Uh,
Well, I know he was talking about such events, people who were operating without the right level of license. That was what he talked about.
oh, well, there's that. Yeah, I mean, attack on
Yeah.
HF. I mean,
Yeah.
that's kind of different. I mean, there's the guy that about 3 years ago that went away from his cabin and accidentally left his radio keyed up for like 3 months because it did take 3 months to find the guy. Although I had something to do with that.
Uh-huh. Did he do that deliberately?
No, as far as we can tell, not.
Ah.
I mean, but that was on what 7033 kilohertz.
Ah.
But yeah, a friend of mine, he owns his own airplane, and
Yeah.
and I will neither confirm nor deny that he was running
Uh-huh.
a directional trailing wire, and
Uh-huh.
nailed it down to a certain area near-ish Grand Junction, Colorado, in that
Uh-huh.
area. And then once that was nailed down, one of the locals, just started driving around
Yeah.
and eventually got lucky.
Uh-huh.
The other one that was weird too is a couple months ago, in up near the top end of the voice portion of 40 meters, somebody was doing two different things. They'd either three different things. They would either send the whole alphabet in CW repeatedly, or they would send the letter A continuously. or they were sending a text that went something like, what was it? It was what was it? Let's see. Oh, I know what it was. Dana, she's as ugly as a catfish. Throw her ass back. And that was just being said over and over and over. And I googled that to see if it was like from a movie or something, and no, it didn't show up as anything. But that was no, and oddly enough, CW is. I mean, I could narrow down with TBOA stuff to a mere 200 or 300 square mile area in the U.S. Yeah,
Yeah.
I know about where it came from, but it's like
not helpful enough. Yeah.
No, it's not like I could get an address.
Yeah.
That's the thing about HF. I don't know if it's stopped. I haven't heard it for a couple of weeks, several weeks now, but I don't know if they got caught or just got bored. But I suspect the latter.
No.
But but then again, I don't know what.
I don't understand.
I don't know what the ARRL observing program is doing these days.
Yeah. No, yeah, you could ask Conrad on Wednesday if he shows up. He probably won't. He's Conrad.
Oh yes, I know him.
Yeah. So
for reasons I have discussed with you, I have reasons to talk to him more recently.
Yeah.
In fact, while on this meeting, I was working on that other reason. So anyway,
I'm sorry. I don't think I'm clued into what you were talking
well,
about.
you remember why it is that I asked you to send those RFI filters? If you don't, I'm not going to say it right now. But
Okay.
But when we're if it's Brett's aware of what's going on.
Okay.
But if we're down to a small number of people on Wednesday, then I can remind you, because I did tell you at one time. But
I'm so buried in coding that all that kind of stuff. But I pulled out a box. Okay. I'll wrap these up and stick it in the box.
There aren't any other broken 888s or anything that
I have two 888s here that are functional. I think you heard both of them.
Well, it sounds like we might get another one from K3LR. I don't know, but not enumerating sounds like a different problem.
Yeah, it's not enumerating. It sounds like a power supply, maybe. Maybe it's
well, it could be the regulator that I've seen fail so far wouldn't prevent him from enumerating, but there's two of those linear regulators in there.
Yeah, yes, I am aware of that. So
it's actually three, but only two of them that are running hot. Was the one that's a K3LR? Did it have the heatsink pad put in?
Yes, according to Nathaniel, that it has a TAPR kit installed. They installed it before they shipped it. So
okay, well that's good.
So it's not that problem. It's not the external clock problem. So
right,
it's a little bit mysterious at this point. I don't think I've seen many of those problems recently. It seems to be.
But I was listening with some amusement on the description of how K3LR, presumably a contest station, has a terrible RFI issue. I've run across a number of contest operators who are not at all technical, and all they care about is, can we hear the number of stations we think we are supposed to be able to hear, and they have blinders on and don't realize and don't look for interference.
Yeah.
So
I'm not sure that the interference that we're seeing
is what they're saying
is what they see off their antennas. So I've been trying to be pretty. Yeah, we're still being recorded. Yeah, so, so Scott mentioned that. Uh, the that the I'm folding your box together. I'm
Okay,
assembling it.
appreciate it.
Of course, if I look a little distracted, is if I always feel like if I should do things when I think of them because otherwise, they tend to slip.
Well, I have I have a whiteboard right here to, and also one on my fridge. So when I think of stuff I need to get at the store or projects that I need to add to my list, that
You put it up there.
well, yeah, and usually the projects that I need put up there are ones that would be fun to do, and they're esoteric enough that that I don't need to do them, but you know, if I have time, it'll be fun.
Yeah.
A little thing like that. But
Well, I've got a project that I gotta turn my attention to. I don't know if you heard. I've one of the residents here has built a scanning electron microscope.
oh, I heard you mention that in passing.
Yeah. Yes. So I told him I'd come down on Wednesday. I just have to. He gave me a little uh little tiny controller board with something called a teeny something.
The teensy,
And
you mean? The teensy controller.
yes, it's well this thing.
Oh yeah,
It's
an Arduino teensy. It looks like.
teensy. Yes, it's a teensy. So it's a so I've got a uh I've got to load up the code on that thing and take my laptop. I you heard the story in my chat. Uh, I was taking my laptop with me on Saturday. Going to be gone all day, and I laid it down on the top of our gray SUV. I
Oh,
forgot it there, and drove down the driveway. And the first turn, it slid off and uh, flew
scattered.
on the ground. It didn't actually. I powered it up, and it looked like it was actually fully functional. But when I got home, I powered it up and realized the leftmost 20% of the screen was the pixels were all
Oh
dead.
yeah, you cracked the display.
So
Is it an
so
Apple?
it's an Apple and it's still under Apple Care Plus. So I took it in yesterday, and they're going to replace it under warranty.
Well, that is one thing about the Apple. You can buy the no matter what how stupid you are warranty.
Yeah,
You know,
yeah, yeah. It's so I mean it would be hard to justify paying to repair it at its repair cost of $600 for the screen, and the technician pointed out that the case body was itself was a little bent by the
right?
where it landed on the ground. So I don't know. I did a factory reset there in front of him, so that they would have the sense that, hey, I'd be happy if you want to replace the whole thing because there's nothing of mine on there anymore. So
I,
we'll see what I get back.
I did that to a handy talkie once, and you know, and drove over it actually. Uh,
Yeah,
but so so if I put anything on the car, I only put it on the hood where I'll see it. And I mentioned
yeah,
that to a friend of mine, and he was camping in the desert a while back,
yeah.
and 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 he was driving. He had set up a campsite, you know, yeah, and was driving down the road to do some day hiking, and then and he'd driven like half a mile, saw his sleeping bag fall off the hood of his Jeep. And he realized that he'd stacked all the gear and he'd been going like this over all the stuff that was on the hood of his car. And, and he had to turn around and and he just collected this huge pile of stuff. It wasn't until the sleeping bag fell off that he
Yeah.
realized that he'd just been
They-
looking straight past all the crap that's on the hood of his car. But
Well,
knowing him, that sounds exactly like something he'd do. Just
yeah.
you can get so fixated. It's like, hi, you know, just
Well, I put it up there to put a plant in the back seat.
oh
So
yes,
and then I it's this, you know, a gray car with
Yeah.
a gray laptop on it is easy to overlook, but it's the most damage I've done to a computer in a very long time. So
Yeah.
it's anyway, hopefully that means that you know, I'm down to this one laptop I use. Uh for what I'm doing.
Yeah.
Anyway, I've run out of subjects here that I can think of, and I think we've driven almost everyone else except maybe
And your
oh
body still your body still thinks it's 20 after 9.
oh okay, here I'm gonna stop cloud recording. Yes.